Okay, so we've talked about entities and relationships. Now it's time to talk about attributes. So, what are attributes all about? Uh, so, let's look at the way attributes appear on the ERD and then we can talk about what they are. Okay, so you can think of attributes as the data fields of the entity. It's how entities carry data. Okay. Do we show them in conceptual data models? Most people do. In my courses, we always do. Okay. Some practitioners only show in the data model, they only show the name of the entity or entity type more properly, and the relationships or the relationship types. Okay. Why do they do that? Well, it's a good way to start a conceptual data model. One of the things that I'm going to talk about later in the lecture is I think the best way to draw an ERD is to put out all the entity boxes and then to connect them all up with relationship lines. We go on in my classes to add the attributes because if you're going to do systems analysis the way we do systems analysis, and if you're going to do conceptual data modeling the way we do conceptual data modeling, if we're designing a database, we need to at least get a list of the attributes. So even though there are some people who don't include attributes on the entities, and even though when we start out doing an ERD, we do the entities and the relationships before we do the attributes. In my class, we always do the attributes eventually. Okay? So, I've kind of said that you can think of attributes as kind of the data fields for the entity. Well, according to Andy Opdahl, here's a couple of things that he says that I like. An attribute is a unit fact that characterizes or describes an entity in some way. Okay, so the attribute describes the entity or it characterizes it. That's what a data field will do. Unit fact is pretty important. It's one fact. It's not a list of facts. It's not a group of facts. It's not a repeating group of facts. It's one fact. Okay? Attributes are atomic and cannot be further broken down. Okay? So it's not a group of facts like the parts of an address. Okay? If there are parts to an address, the way we think about address, like street address 1, street address 2, city, state, zip, each of those are the attributes, okay? Because we can think of them on their own, okay? Atomic, unit, fact. All right? Attribute names should be singular nouns. Examples: first name, city, state, transaction amount. So let's go back and look at that example, and we can see, okay, for customer, we've included the customer ID, first name, last name. Now, do we think this is an exhaustive list? No, probably we're going to have the parts of their address and a lot of other things. That's all I had. That's all I wanted to put onto this particular example. Okay? Okay. Now, let's find out some more about attributes. Okay. You're not going to be surprised to hear that attributes on ERDs are really attribute types with type instance semantics. Oop, these are all types. Why is that? Because there are no instances on ERDs They're designs, they're types. They're designs for things that get implemented in data stores. Where do the instances show up? Well, they show up in the data stores. Let's look at this. Okay, so we have an entity called city. It looks like a kind of a lookup table entity. Okay, we have city ID and city name. Okay, now are there any instances here? No instances. Okay, ERDs are not about instances. But when we implement this in a relational database, what do we get? Well, we get a city table. Okay, and it would have a city ID column and a city name column, and it would have a row for each city, okay, that would include values for the city ID and city name and uh, whatever other attributes would be included in the entity. We'd have a column for them in the relational database table. So where where are the instances? Well, the instances are in the implemented data store that the ERD is the design for. That's why these things that we see on the ERDs are technically attribute types, not attribute instances. Okay? Now, having said that, what do people call them? Do they call them attribute types? No, just like the rest of these things. Because ERDs are only about types, they're only designs, there's no instances involved, we call them attributes. Is that speaking loosely rather than precisely? Yeah, but people do that in a lot of professions and we don't sweat it. Okay? Okay. Couple of other things that I want to show you. Okay. One is on conceptual data models, there are two groups of practitioners. They are me and the people who take my classes at the iSchool. Okay. And there are people who are maybe less discerning than us with respect to this issue, which is what about if we could derive a particular attribute value from other attribute values? Would we put the derived attributes in the data model? And the answer is going to be, for us in my class, no. Okay? Why? Because they'd be redundant. Okay? So let me show you what redundant attributes look like. We'll look down at the bottom here. So here's the classic three table order item. And I'm sorry, I just say table, I mean three entity. Okay? Because this is a conceptual data model, right? The order entity represents the order itself. The order item entity represents each line on the order. Okay? And the item entity represents the product. Okay? So each order item or order line is only for one product. Okay? And we keep the quantity that we sold, the actual price, and you can multiply the quantity times the actual price and get an extended price. So a lot of times you'll see that as a column on the printed invoice. Okay, you can see that the modeler here decided that they were going to list it on the conceptual data model. Okay, in our class we're not. Why? Because any derivable attributes are redundant, and redundant facts in data stores create opportunities for conflicting data facts. Okay? And we, coming from an information science point of view, we definitely don't want to be recording conflicting data facts. And so our ERD, which is the design for the data store, we're going to leave out redundant data facts. So even though some of the users might want to see us have extended price in here, we're going to tell our users that yes, when we display this for them, we are going to display an extended price, but we're not going to store it because it would represent a redundant data fact. The same thing with shipping amount. I'm sorry, a total amount. So in our class, we're going to show on the order, we're going to carry the tax amount and the shipping amount, okay? Are we going to carry the total amount of the order? No. Anybody who wants to get the total amount of the order is going to add up the value. They're going to do the multiplication here, and they're going to add up the extended price of all the order items, and then they're going to sum them, and they're going to know that that plus the shipping amount from the tax amount is the total amount of the order. But are we going to show it explicitly recorded on the entity? No, we're not, because it would be a duplicate fact prone to contradiction. Okay? So, in our class, we're not going to show, even on the conceptual data model, any redundant attributes. Okay? Do some practitioners show them? Yes, they do. It keeps their user community happy. Okay? We're going to rely on ourselves to be good enough at talking to our users that we can explain that they're not there physically, but they're there in spirit, because we can derive them from everything we have on the list. Okay? So, another thing that is sometimes surprising to people who have worked with relational databases is that on ERDs we don't show foreign keys. So in a minute or two, we're going to talk about picking attributes that are going to be the unique identifiers for each entity, okay? And we're going to use this ID text out here to show that team ID is the unique identifier for the team entity, and that player ID is the unique identifier for the player entity. Now, if you're used to these things being implemented in relational databases, okay, you'll see that we'll put a PK here saying that the team ID is the primary key, and we'll put a PK here saying the player ID is the primary key of the player table, and we'll put an FK down next to team ID to say that's the foreign key. Okay, well, in conceptual data models, we don't have to show these implementation details. We do have to show that we have a unique ID, because that's the nature of conceptual data models. But these details, primary keys and foreign keys, are not part of conceptual data models. And in particular, even including the foreign key here is an implementation detail of a relational database. It's not going to show up until we move on to logical database design. Okay, so no foreign keys, no primary keys either. Okay, although you need a way to show what the unique ID is. Okay. Now, one more thing about the style that we're using with respect to attributes uh, in my classes. It has to do with the following issue. Okay, are we going to show um, are we going to show attributes um, uh, that you can sort of imagine them as being just free-form text fields, right? So here's what we have. We have some kind of um, e-commerce thing. So we have these transactions. You know, people are giving us orders, and they're paying for them. Okay, and we uh, let's say that these people have credit cards, and so even though in terms of security there are a lot of organizations that are not really keeping credit card information on hand because they don't want to be responsible for it. Let's imagine that we are. So we're going to have a credit card entity, okay, and uh, uh, it's going to have a credit card issuer and a credit card number. Okay, so like American Express is the credit card issuer, and the credit card number is 12345 all the way to about 15 digits. Okay. Are we going to show credit card issuer as an attribute? Or are we going to show that we're going to control the values for credit card issuer by having a separate entity and a relationship to the entity? Well, we're going to do this former one, okay? We're going to want to show wherever we've got some value that we would show as an attribute, but we need to control it, okay? We'll show a separate entity that we have a relationship with, okay? Now, it's the same fact, okay? What do we get from the relationship to the other table? Well, we will connect to an instance of credit card issuer, but this entity eventually implemented as a relational table, it will become the list of valid credit card issuers. Okay, so some people, even if they intend to do that eventually in a logical database design, they'll not show that in a conceptual data model. They'll just show credit card issuer. Okay, because of our pedigree as information and library scientists, um, controlling values is very central to our point of view. Okay, so I'm going to expect to see you show a relationship to some kind of value control entity on your conceptual data model. All right? Good. Now, we showed identifiers just briefly. Now let's get into identifiers more fully. So it's up to the data modeler to choose a unique identifier from among the attributes of an entity. Okay. Now, sometimes you may have to refer to more than one attribute as being part of the unique identifier in order to get a combination that is truly unique. Okay. We typically position the unique identifiers at the top of the attribute list. And sometimes you'll see the entity box drawn with a dividing line, and things above the dividing line are part of the unique identifier. Attributes above the dividing line are part of the unique identifier, and below the dividing line are just plain old attributes. We don't do that with our diagrammer. Here's what we do. Okay. So what we do is what we're showing on the right here. We're going to use a two-column um, entity box from Lucid Chart, okay? And we're going to put the unique identifier, in this case, customer ID. We're going to put it all the way up at the top because that's where you typically have it. And in the left column, we're just going to put a capital ID to say this is the unique identifier. If the unique identifier were made up of two or more attributes, then we would have ID in front of all of them, and they would all be segregated at the top. Now, another thing that you'll see data modelers do, and you'll see instances like this in textbooks, is that they will, again, position the unique identifier or identifiers at the top, and they will make the text bold and underlined. Okay? For our purposes in my courses, it's going to be easier to do it with this two-column ID scheme. Okay? So this is what we're going to do. Okay? But you may see it the other way. I have already told you this, so I'm just going to show it. No foreign keys. Okay? We don't use foreign keys in conceptual data models. Now, I don't know if you've thought about this, but what if we have a relationship that represents a fact in the database, okay, and it needs to carry some information? Like, wouldn't it be nice if attributes were able, relationships were able to carry attributes? Well, there are some diagramming strategies in which one can show attributes hanging off of a relationship. It doesn't really work with our diagrammer, and so we don't do it in my courses. Okay. So what do we do instead? Well, what we do instead is that we represent attribute carrying relationships with an entity type. We turn that relationship into an entity that bridges the two primary entity types. So this is going to be easier to understand if you see it. Okay. So let's just see the way that works. So let's say that we begin with a many-to-many between employee and skill, where employee has skill. All right, that's working fine. Now, what if we want to know more information about in what context they have the skill? The two that we typically use are, what's the date that they acquired the skill? And maybe, what's the level of proficiency that they've attained? Well, here I decided that we were just going to record the date that they acquired the skill. So rather than having attributes carrying, relationships carrying attributes, which they don't really in this kind of diagramming scheme. Okay, here's what we're going to do. We're going to create another entity that we call an associative entity, sometimes a linking entity, and we're going to put the attributes on that. Okay, now one of the things that you will notice is that even though I've diagrammed this relationship which carries data as an associative entity, I haven't named the relationships that are connecting it to employee and skill. And typically in my classes, we don't. And why is this? Well, the name is actually coming from the um, the name of the entity itself. Okay, and how do we name it? Well, if we have a term of art for this, um, like some people might call this employee has skill. Okay, it's more typical for practitioners to just use the names of the two um, entity types that they're connecting and separate them with an underscore employee skill. So that characterizes the relationship. So to name this entity and then also to name the relationships, you're going to run out of names. Okay, so only name the entity. You can leave these unnamed. Now, you'll see here that in the way we diagrammed this, okay, we used the dashed lines and we gave this entity its own ID. Okay. In some diagrammers, okay, if you don't give uh, the entity its own ID, okay, then you'll get solid lines, okay, that connect this uh, associative entity to the neighbors, and the implicitly the identity is borrowed from the two neighbors. Okay, so if you were going to implement this as a relational database table, it would get the combination of employee ID and skill ID as the primary key. But this is a way to diagram this in conceptual data model. And these solid lines are called identifying relationships. And people call this kind of entity, which is connected by these solid line identifying relationships. They call it a weak entity. Um, I prefer the design here in the middle and not this one at the bottom. Okay, so this weak entity stuff, I think, is a little bit of a waste of intellectual effort. So the design that I'm recommending to you is the one where it does carry um, its own identifier. Okay? All right, that's that. These entities that we put in between in order to carry data for a relationship, they're called associative entities, or sometimes called linking entities, or sometimes called intersection entities. All right? Okay. So let's talk a little bit longer here. I want to talk about the conceptual data modeling process next. Okay? Because having learned about conceptual data modeling, I want you to think about how you're going to put it into practice. Okay? So first of all, you've got to think about who the participants should be in the process. And here's a list of potential participants from the Andy Oppel book. The executive sponsor, that's the person who's funding the project. The business user, that would be users who would use the system. The business analyst, that's maybe a systems analyst who's not going to be the data modeler. Subject matter expert. This could be anybody who knows things from the business that would be of interest to the data modeling. Data modeler, that's us. Process modeler, that's the person or persons who could be us, uh, who created things like use cases or user stories when we were trying to document the process requirements for the system. Uh, Database administrator, self-explanatory. Enterprise architect, usually a high-level person who helps uh, pick, tries to create a common technical approach in an organization across a wide range of systems. An operations specialist here, in my mind, would be a person who had to support the data store um, operationally. Maybe a person who would respond to problems if there was a crash of a database. Okay, uh, what kind of inputs are we looking for? So we've got the participants, we've got the inputs. Okay, well, to the extent that we've already created process models for the system, we might have things that look like user stories. These are things that we learn how to create in my systems analysis class. Okay, so uh, we would have that. Uh, or if we're taking a more traditional approach to developing the system, we might have use case specifications that might look like this. Okay, in either case, we're talking about how does the user interact with the system to get their job done. Okay, that would be interesting when we're trying to figure out what data the new system uh, should hold. Okay, you might want to, if there's an existing system that we're replacing, sure, you might want to look at the documentation for it, although it could be old and out of date. But actually look at the data. What's in the database? What's in the data store that supports the current system? A lot of times you'll find things that they're doing in the data that are informal features that you're not going to discover in any way other than looking at the data in the current system. Okay? In the Andy Oppel book, he talks about generic models. And a good example of this kind of models is there's a whole series of books by this fellow, Len Silverstein. Um, and he's got these things that he calls universal data models. And they're very general. Um, this is a 3-volume set. And I can't say that I have it, but I think it's an interesting idea. Okay, so I just wanted to include that. Uh, and another thing is that a lot of industry associations have um, in their working groups and such sort of documented kind of data best practices for their industry. And sometimes you can find those kinds of data models. Now, the only warning that I have for you is that both, the industry data models and those generic ones from the books that I pointed you to, they're all very detailed. They have a lot of features. So you, as a beginner, I think your best way to use them is use them for inspiration. If you try to adapt them in whole, they'd probably be much more detailed than you need. Okay? So for the beginner, take inspiration from other people's data models, but don't feel obligated to use them, especially don't feel obligated to implement all the features. Um, when you're working on the data model, how do you elicit the requirements from the stakeholders? Well, you could do interviewing. That's always considered the gold standard. We talked about looking at documentation and data for existing systems. But a really good thing and something that we practice in my course is a brainstorming session where you bring the participants in and you brainstorm about what should be in the database or in the conceptual data model in this case. And so um, one of the approaches that I teach is this kind of brainstorming approach called the rag bag exercise that I highly recommend. How do you draw the conceptual data model? Well, I mentioned this before, but I want to emphasize it again. Uh, Begin by drawing the entities. Draw the boxes with your diagrammer. Then add the relationships. Okay. And when I mean add the relationships, draw the lines, name the relationships, pick the cardinalities, all those kinds of things. When you have that to your satisfaction, add the attributes. Okay, when you've added the attributes to your satisfaction, choose the unique identifiers. And then you're done. So then the question is, are you done? Right? You've come to the end of a particular version of the conceptual data model. I think you ought to look at this as an iterative kind of process. Okay, so you create a version of the ERD, the next one. Okay, you need to review that ERD with the stakeholders, get their feedback. Hopefully, they've been involved all along. Okay. You need to evaluate the model in light of everything you hear from the stakeholders. Okay, is it complete? Is it concise? Does it support functional requirements? Complete and supporting functional requirements are kind of two expressions of the same idea. But I want to talk about especially concise, which is to say, we don't want redundant information in the data model. Okay. Now, most people who are involved in a three-step database design process, okay, they don't worry about things like redundant information until they get to step two, logical database design. Okay. But given the information science and library science perspective that we have at the iSchool, well then I'm going to suggest that we don't want redundant features even in our conceptual data model. Okay, so that's what we mean by concise. And then, after we've looked at all this kind of stuff, we have to say, are we done yet? And I think you need to look at that in context, right? If you're doing systems analysis and you're going to stop after the conceptual data model, okay, and it's going to be a way to express the data requirements, okay, well, then you want to make sure you have everything very tidy and done. But let's say that you're working on a three-part database design project for a relational database. Do you have to have every little bit of the conceptual data model perfect before you start the logical database design? No. You can allow yourself to discover new requirements when you're working on the logical database design. Um, can you allow yourself to discover further requirements when you're working on the physical database design? Yeah, I think you can, right? So if it's part of a three-step process, um, I think that you should feel comfortable in uh, being done, but not, you know, other requirements are going to come up, okay? And you'll deal with them in the phase that you're in, okay? So, yes, we want to iterate this until we're done, but I think we need to have a constructive standard for being done. I'm not going to talk about supertypes and subtypes yet. That's going to be in a separate part, so I'll say bye for now.